Sustainability, which is obviously a very important part, and graphene and 2D materials plays an important part in decarbonisation. I'd like to now introduce you to Dr. Burcu Saner Okan, one of our partners, and going to give a talk on sustainable graphenes. Thank you.
Thank you so much, and thank you for your invitation and for this impressive event. Today I will talk about my journey. I've been working on graphene since 2007 from my PhD, and also I'm working on sustainable products more than 10 years. And in my journey, I mostly focus on the scaling up graphene with environmental technology. So I started looking for the opportunities instead of using graphite, what I'm going to use to get some carbon source 10, 20, 15 years ago. Then, this is my second spin-off, and first starting from graphene, but I need to change my business plan to get investment. So also business plan to get investment are very important things in this entrepreneurship journey. What we are doing in Euronova especially focus on the sustainable plastics. And we have very big problem, and then there is a very big crisis now around the world, and then there's a big global warming problem, and we are focusing on reducing the carbon dioxide emissions, and there are also lots of carbon taxes coming in different platforms in the industry. Here that we are enhancing the properties of the recycled materials, renewable materials, by integrating graphene as a supporting additive in the compound formulations. And what are the drivers here? In fact, I listed three main drivers in recycled plastic. People want to use, for example, automotive makers, it's mandatory to use 25% and their end-of-life vehicles in their compound formulations. The authorities and regulations increase, and also there are some challenges in the usage of the post-consumer materials. What is that? There's also inability in efficiency problem here that. And then the market is still growing and growing. And there are some constraints, especially the usage of the nanomaterials in scaling up in commodity products. Yes, there are lots of good examples in small scale. But what about the efficiency? Because when you scale up the technology, everything, all the thermodynamic energy change. So how you should control this? So therefore, we see the inefficiency, especially in graphene, in extrusion, in large-scale screws, and then is a little bit big processing and a big problem for the commodity materials and mass production. And here that Euronova focus on some circular mission and just only focus on the bio-based and recycled plastics, and instead of using conventional additives like glass fibers, carbon fibers, we are using some natural fibers and recycled carbon fibers. Whatever coming from the industrial process, we're trying to enhancing the quality of the materials with new compound formulation. Instead of giving a secondary solution, we are providing prime solution to the industry. So this is the growing strategy. Especially, I would like to show this because 10 years, I only worked here, getting some carbon blacks and then focusing on graphene production and giving to the additives to the many industry. But I look at that, I'm in the beginning of the value chain. So I need to change my business plan, and then I focus this pyramid. And then, there are lots of compounders in the market now. This is not like being a compounder, because the compounders focus on just only the big scale, not sustainable products. In their business, just about a 5% on 10%. They are using still a good PR for these projects. But here that Here we use especially recovered carbon black. Normal carbon black does not work. Here that, especially during the pyrolysis, if you keep the pyrolysis condition, especially under inert atmosphere at the defined temperature, you can get suitable oily carbon black that can be converted into the graphene in the presence of catalyst that you define. I also applied PCT patent about this after keeping the technology as a trade secret more than 10 years. Then I need to get some license. So then this pyramid very important. Yeah, there are it is not easy go down, especially commodity plastic, but this can be polypropylene. And in engineering plastic, we have a high chance because polyamide, the price can compete, and then you can use graphene much more there. And engineer high temperature plastics like PEEK and other aerospace polymers, that is also a good opportunity to find a good market here. And in the especially in the automotive market, lightweighting is a priority, and then also taxes is increased, and there are lots of regulations coming from the carbon dioxide emission. You know that therefore electrical vehicles and hydrogen-based vehicles are coming in the following years too much, but there are good examples in European projects and also in the United States. There are lots of good examples, but they are using in just only one period, not continuously. So the problem is that it is important to make a continuation. First of all, we are starting with end-of-life tire and getting carbon black. It's about a 35% recovered carbon black. And here that we need to profile to get the carbon black efficiency to the conversion of the graphene-like structures. This is not a graphene sheet in the end. This is a platelet form in the bulk form, and that can be used as an additive. Instead of using compatibilizing agent in the compounds or additives, you can use as a multifunctional additive in one formulation. And then this brings especially advantage in cost. In the commodity products, especially, the problem is the cost. Why we are not seeing this material in the commodity systems? The problem is that. Just only one reason. So what we are doing here, by using this hybrid additive, instead of replacing all these things with the graphene, just adding, for example, minimum 1 weight %, and then combining with this recycled polymers, recycled fibers, also natural fibers. So I would like to show some prototypes that we made, and these are validated by OEM standards. This is also Toyota part. I would like to just only focus on the compound formulation. This is, for example, Copo PP with graphene, and using the engine undercover. This is clutch pedal case made for Ford. And this is made again using for Ford Transit fuel lead carrier. Everything contains graphene in the compound formulation without changing the mold, and then without changing the conventional process in serial production. And this is the last part which is validated by Renault, and now it will be used in Megane in the following years. Also, this is now in serial production. Arçelik now, it becomes Beko Global. Most of the people using their white goods in their houses. So here that what we did, we use recycled polyamide and with glass fiber. In the serial part, they are using a virgin polyamide. Now we change, and then here we add 1 weight % graphene, and then we keep the mechanical integrity because of some loss coming from the recycled plastics. So we prevent, and then we provide cost advantage. Now the formulation is under serial production, and then we will produce 200 tons per year next year with this formulation just for this part. And then this was also validated, but not include graphene yet. But this is a natural 2D mineral acting like graphene, and then just 15%, and then recycled polyamide coming from cord tire, And this is validated by 3 OEM. Now, in this November, with our new extruders, we will start to produce this material 1,500 ton per year for 3 OEMs, and then we will extend the technology. So, and also we would like to push the people to use natural fibers. Yes, there are specific examples, and the problem is in this natural fibers, the odor, and then also the sizing problem. Here again, graphene can be a good solution, eliminate the odor problem, and then acting a good compatibilizing agent within the selected matrix. And then again, in this matrix, we are formulating the formulation with hemp fibers, flax fibers, or other fiber forms in the chop form, but not in the continuous form. In the chop form, you can use these materials instead of long glass fiber. I would like to show one example. For example, in the top, you can see 40% long glass fiber with homo PP polymer, which is under serial production for Renault parts. And then with new one, you can see 40% hemp fiber with 1% graphene. We can cover most of the density, flexural modulus, and also tensile strength values. And also the other benefit is the reduction in carbon dioxide. If you use recycled plastics, it is much better because everything goes down. So therefore, we are triggering the usage of this kind of materials in new business plan of Euronova. And also making foams, also focusing on thermoset system, thermoset polyurethane, and then changing their cell size, and then we can control the also mechanical properties and also noise. You can see we improve the noise reduction here by the addition again 0.05 weight%. Also, it is very feasible to use in footwear. We are also working with BSF and Adidas to use these materials in their shoes. And this is our new project. We are very excited. Euronova is a part of the RIC2D program, and then we will work with the aerospace and automotive companies within the market with this new funding, and then we are very happy to be a part of this project. And then again, this, in fact, the business plan a little bit modified with this project. So we will see also the results of Euronova, and by starting from the recycled materials to the end product with the support of the OEM within this project, within the Light G-Comp project. There are several products and services to the OEM and also with the compounders. So we are also working with our competitors, and then they are coming, and then we are developing some co-branding with them. We have some LOEs and NDAs. So, and then also addressing the United Nations Sustainable Development Goals. This is also important. Yeah, also the factory plant, everything designed for carbon dioxide emission and then environmental concerns. So therefore, we are also being an environmental friendly factory in the end, as an example to all the companies. This is our team. Here is a little bit different, especially in the investment period. Instead of giving directly from the companies, we got investment from C-level of companies from the automotive industry, and then they are a part of Euronova, and then initiating the technology in the Turkey market, also in the European and other market together with this group. At this time, I'm not a CEO. I'm just only working on the technology. Yeah, this is very good business for me because I'm also academic person. So I would like to continue my research, supporting all these activities. So these are our partnerships now. The numbers is growing, and so thank you so much.
Thank you for a very good insight into sustainable use of graphene technologies. Any questions, please? We've got one.
One of your slides showed use cases for OEMs, like plastic parts of the engine cover, I think it was a Ford part.
Yeah.
And you said you achieved like a 10 or 20% weight reduction, I can't remember. Were you using the same tool?
Yeah, it's just only compound formulation change. For example, instead of using 35 glass fiber content, we are using 25% together with graphene. Yeah, graphene do not increase the whole modulus values by replacing glass fiber, but it support. Yeah, you can keep the mechanical integrity. So you didn't change. Yeah, you did. Yeah, even reduction in glass fiber, and then you didn't change the mold. Yeah, if you change mold, there is a problem for serial production.
Yeah, so it's the same part of geometry. You get a lot because you've reduced use of glass fiber.
Yeah, especially dimensional analyzers made for each trial, and then also there are some stress tests. For example, you are producing 100 kilogram first, the first initial part. Then in the second stage, you need to make 1.5 ton in serial production in different time interval in the factory. And then you are also controlling the dimension of the parts, getting each of them during the process, and then optimizing.
There is geometry optimization.
Yes, exactly. Crystallinity, but it's a good agent again for crystallinity.
Good, thank you.
Any more questions? Okay.
No.
Thank you.
Thank you so much.
Thanks
Thank
very
you.
much.